Good afternoon. The topic of today's presentation is error, their types and measurements. So first we will define what is an error. So some errors, they are due to human being. For example, if we are not using the equipment correctly, then there is some error because of the equipment. So let us look at some examples of the error. First is human error. Like one person is trying to measure the length of a piece of a boot. Here it looks like it is 95.4 millimeter to me. He said it looks like 95.4 millimeter to me. So what he is doing wrong, because he is taking in the opposite scale. So how many mistakes can you find? There are number of mistakes here in this measurement. So the first error is he is measuring from the 100 end, not from the 0 end. So second is 95.4 is wrong number. Third is millimeter is wrong in it, because the scale it measure it in centimeter. Fourth is his hand is bobbling, so handheld object it tends to bobble. Fifth is there is some gap between the object and the ruler, so it will not give the accurate reading. And the last one is end of the object not at the end of ruler, and eye is not at end of the object. This is called parallax error. So when we are doing any measurement, we need to take care of all the things like unit, number, parallax error, and the accurate reading of a machine. And last is he is on the wrong side. He should be in the front of the scale to see the exact reading. So second example is when we are reading a scale, so this type of error is called parallax error. So if we are measuring, if we are weighing the scale from the position 1 or position 3, then it will not give the accurate reading. But if we are at position 2, then it will give us accurate reading. This type of error is called parallax error. So second is the best reading. First and third, they will give us a wrong reading. This is called parallax error. It is due to the gap here between the pointer and the scale. So this gap will create a error that is called parallax error. Should the gap be wide or narrow? This gap should be narrow. So when we get anomalous result, when you are doing any practical, you may get an odd or inconsistent or anomalous reading. This may be due to many reasons, like simple mistake in reading a scale. The best way to identify an anomalous result is to draw a graph. For example, look at this graph. If we are increasing this dimension, x dimension, then y dimension is also increasing. So it will give us a linear curve. But this reading, third reading, it is away from this line. So this is the anomalous reading or inaccurate reading, which affect our whole system. So which result do you think may we get from anomalous? A result like this should be taken again to check it. Next we define error. If we are doing any physical measurement, there is always an error involved in this. This error is notated by using a symbol delta followed by the variable representing the quantity measured. Like if we are measuring the physical quantity like volume, then its error is defined as delta of V. So, delta is because of error, V is the variable that is which we want to measure. For example, if we are measuring volume, the error in the measurement of the volume, it would be symbolized as delta of V. So, we can easily calculate error. Error is simply the difference between true value and approximate value. So, here error E is equal to true value minus approximate value. Next one is one example regarding the error. Find the truncation error for x is equal to e raised to power x if the first three terms in the expansion they are retained. So, error is equal to true value minus approximate value. True value of this expansion is 1 plus x square by 2 factorial plus x cube by 3 factorial up to so on, and approximate value is up to 3 terms. So, first term is 1, second term is x and third term is x square by 2 factorial. So, by taking the subtraction of these two values, we will get error is equal to x cube by 3 factorial plus x4 by 4 factorial plus x5 by 5 factorial and up to so on. Next, we will define different type of errors. So, there are many type of error. First one is gross or human error. Second one is random error. Third one is systematic error. And next one is constant error, absolute error, relative and percentage error. So, the first three error, gross error, human error, random error and systematic error, they come under the category of static error. So, first we will define what is static error and what is gross or human error. As clear from its name, it is caused by human mistake in reading or using any instrument or measuring any physical quantity. Gross error may also occur due to incorrect adjustment of the instrument and computational mistakes. It can be treated mathematically. It cannot be treated mathematically because it is because of human error. It cannot be eliminated, but we can minimize by taking care of all the things which give us inaccurate reading and improper use of an instrument. This error can be minimized by taking proper care in reading and recording measurement parameter. In general, indicating instruments change ambient conditions to some extent when connected to a complete circuit. Therefore, several readings, at least 3 readings, must be taken to minimize the effect of ambient condition changes. Second is systematic error. It is due to shortcomings of the instrument such as defective parts or bone parts of the instrument or maybe the effect of environment. Like if we are doing one experiment with the magnet, if there is some another magnet in the surrounding of that magnet, then that environment will affect our machinery. So, and another example, like if we are doing some experiment in dark room, then suddenly some light appear in that room, then that light will affect our experiment which we are doing in the dark room. In general, systematic error can be subdivided into static and dynamic error. Static error, they are caused by limitations of measuring device or physical law governing its behavior. Dynamic, they are caused by instrument not responding very fast and to follow the changes in the measured variable. There are mainly three types of systematic error. First one is instrumental error, second one is environmental error, third one is observational error. So, what is an instrument error? It is the inherent while measuring the instrument because of their mechanical structure. Like if we are taking a reading from the D meter, there is some friction because of the bearings of various moving component. So, that will give us some inaccurate reading. So, this error, instrumental error, they can be avoided by selecting a suitable instrument for a particular measurement application, or we can apply some correction factor by determining the instrumental error, or we can calibrate the instrument against the standard. Another example of the instrumental error is the zero error, or we can say in the screw gauge there is backlash error, which comes under the category of instrumental error. Second type of error is environmental error. It is due to external condition affecting the measurement, including the surrounding area condition such as change in temperature or humidity or barometer pressure, etc. They can be avoided by using an air conditioner or sealing certain component in the instrument or using the magnetic shield. Third one is observational error. It is introduced by an observer which is doing an experiment. It is most common parallax error and estimation error. Its types are parallax error and estimation error while reading the scale. And its example is if an observer who tend to hold his head too far to the left while reading the position of a needle on a scale, too far to the left or too far to the right. So, both positions they are not accurate, but if he is in front of the scale, in front of the object, then it will give us the accurate reading. Third is random error. It is due to unknown causes and occur when all the systematic error has been accounted. It is the accumulation of small effects and it requires a high degree of accuracy. It can be avoided by increasing the number of readings and use statistical means to obtain best approximation of the true value. So, systematic error, now we summarize what is systematic error. Systematic error is caused by any factors that systematically affect the measurement of a variable across the sample. For instance, if there is loud traffic going by just outside of a classroom where the students are taking a test, then this noise is liable to affect on the children's course. In this case, this noise will systematically lowering the numbers or marks of the students. Unlike random error, systematic error tend to be consistently either positive or negative. Because of this, systematic error is sometimes considered to be bias in the measurement. So, these error cause readings to be shifted in one way, either in the positive side or in the negative side from the true reading. So, your results will be systematically wrong if you are getting plus minus something. Let us look at some example. Suppose you are measuring with a ruler. If the ruler is wrongly calibrated or if it expands with the temperature or heat, then all the readings will be too low or too high. So, either it will systematically lower that reading or it will systematically high that reading. Next example is parallax error, which we already discussed. If you have parallax error with your eye always too high, then this will give us systematic error. So, the reading is always higher than the actual value. So, the main motive for all this example is because the systematic error is either it is in positive direction or it is in negative direction. A particular type of systematic error is called zero error. Zero error is mainly in all the instruments like vernier caliper, screw gauge, in our watches, ammeter, voltmeter. Here are some examples of the zero error. First one is spring balance. Over a period of time, the spring may weaken, so the pointer, it does not point to 0, then this type of error is called zero error. If the 0 of the main scale and 0 of this spring, they are coinciding with each other, then there is no zero error. But if there is some deviation from this 0 to the pointer, then there is some zero error which either increase the reading or decrease the reading. So, look at this balance, top and balance. There is reading 0.02 gram. So, it will always systematically higher the mass. So, it has some zero error. There is nothing on it, but it is not giving the value 0. Ideally, it should give 0.00 if there is nothing here, but it is giving 0.02 grams. So, it will have some systematic error of 0.02. Next example is, look at this ammeter. Here the pointer, this pointer is not at the point 0, which is the 0 of this ammeter. So, this symbol represent it is an DC ammeter and A is for ammeter, and this pointer is not at position 0. So, this it will give us some error that is called zero error. But one thing, but we can reduce this error by looking at the mirror below this pointer. There is some mirror here which give us whether the pointer is at accurate position or not, whether it is giving us 0 error to be 0 or not. Next example is voltmeter. So, this is AC voltmeter. Here the 0 of this scale is not matching with the pointer at initial position, that is it is below. So, it will give us some 0 error. So, we can use this screwdriver to adjust that pointer up to 0. So, we can calibrate this voltmeter. Next example is again ammeter. So, there is some error, it may be due to parallax error because its position is not accurate. Is it a 0 error or parallax? So, we need to look at in front of that instrument to check whether it is an 0 error or parallax error. So, it has some mirror behind this pointer near the scale. It is for to check whether it is parallax error or not. When the image of the pointer in the mirror it is hidden by a pointer itself, then we are at 90 degree and there is no parallax error. If we are able to see both the things like image of the object as well as the pointer, then there is some parallax error involved in the measurement. So, random error, it is caused by any factors that randomly affect the measurement of a variable across the sample. Each person's mood can inflate or deflate their performance on any occasion. In a particular testing, some children may be in a good mood or others may be depressed. Mood may artificially inflate the scores for some children and it will artificially deflate the scores for other students. So, random error does not have consistent effects across the entire sample. If we could see all the random errors in a distribution, then their sum would be 0. The important property of the random error is that it adds variability to the data, but it does not affect the average performance for the group. So, while we are doing the while we are taking care of random error, we need to take care or average of all the readings which we have taken for that measurement. So, random error, they are not inherent to the measuring process. Frequently, they are introduced by external factors that cause a scattering of measured data. When the scattering is distributed equally about the true value, the error can be mitigated somewhat by making multiple measurements or averaging the data, total data. For example, vibration in mechanical devices, it produces random error. In electronics device, the noise produces some random error. A random error due to human, maybe due to human or faulty technique or instrument. To reduce the error, then take a number of readings, then take the average or mean of the number of readings. So, next error is constant error. When the result of the observation are in the error by a same amount, the error is said to be constant error. For example, if a scale of 15 centimeter, it actually measures 14.8 centimeter, then it is measuring 0.2 centimeter more, that is 15 minus 14.8, 0.2 centimeter more in every observation. This type of error, it will be same in all the measurement done by scale. So, there are another types of error. Three other way of defining the error. They are absolute error, a relative error and percentage error. So, we can easily find out the absolute error in that measurement. So, it is basically the difference between true value and approximate value, that is x minus x prime, it is called absolute error. And a relative error, it is the ratio of absolute error to the true value. If we are taking the number of measurement, then true value is the average value of all the measurement. So, relative error is the ratio of absolute error to the true value of that measurement. So, ER is equal to x minus x prime over x. One example of absolute error. The difference between the measured value and the true value is referred to as the absolute error. Assume that the analysis of an iron core by some method, it gives 11.1% while its true value is 12.1%. So, the absolute error is 11.1 minus 12.1, it is equal to minus 1%. And we can easily find out the relative error. A relative error is the percentage of the absolute error to the true value. So, relative error is absolute error upon true value, it is equal to minus 1 divided by 12 and it is equal to 0.08. But if we want to find the percentage error, then we can multiply this relative error by 100 and it comes out to be 8.3%. Next is relative accuracy. The percentage of the quotient of the observed result to the true value is called relative accuracy. The relative accuracy is equal to observed value divided by true value into 100. So, the observed value is 11.1 and true value is 12.1 into 100, it will give us 91.7%. So, the relative accuracy is 91.7%. Next is percentage error. It is simply multiplication of a relative error by 100. So, EP is equal to 100 of ER and it is equal to 100 of x minus x prime divided by x. Next example is, suppose 1.414 it is used as an approximation to square root of 2. Find the absolute, relative and percentage error. So, the absolute error, it is a difference between true value and approximate value. True value is given 1.414 minus 1.414. So, the difference of these two will give us absolute error. Next is the relative error. It is the ratio of the absolute error divided by true value. So, absolute error we already find out 0.000021356, true value is 1.414211356. So, the ratio of these two, it will give us 0.151 into 10 raised to power minus 3. And last one is percentage error. Percentage error is simply multiplication of a relative error by 100. So, it will give us 0.151 into 10 raised to power minus 1, which is percentage error. So, next example is true value of a physical quantity, it is given to be 122 millimeter. and expected value is 120 millimeter. So, absolute error, it is true value minus expected value. True value is 122 minus 120, it is equal to 2 millimeter. A relative error is equal to absolute error divided by expected value.